8C, area. So the area is the space occupied by a two-dimensional figure or object. When we talked about perimeter, we talked about triangle, rectangles, and squares, and we're going to do the same thing here. So we have a triangle. We're going to define the area based on two dimensions. We have lowercase h, which stands for the height, and then we have lowercase b, which stands for the length of the base of the triangle. So the length of this side, the bottom side, the base, and we're going to have the height of the triangle. The area for a triangle is found by taking 1/2 times the base times the height. 1/2 times the base times the height. And that's going to give us the area of the triangle. If we have a rectangle, remember a rectangle we had a length and a width. The area for a rectangle is found simply by multiplying the length times the width. So just length times width. For a square, remember that for a square, the length of all the sides was the same. So, and we use S, and I'm going to stick with that, so it's S. Well, remember a square is just a special case of a rectangle. So really, the area is equal to the length times the width, which is S times S, or S squared. So the area of a square is just the length of a side squared. And that's going to give us the area. So let's look at a few examples of this. So remember, for area of a triangle, 1/2 base times height. Area of a rectangle, length times width. Area of a square, S squared. Before I get into example, I just want to show something else with the triangle. Please note that not all triangles look like this. A triangle could also look like this, where this is a right angle, and therefore that would be the height, and that would be the base. Still, the area is 1/2 the base times height, but it just looks a little bit different. The one that really looks a bit different is when you have something like this. We still have a base, but the height has to be projected off to the side here. So this is our triangle. The solid lines form our triangle, but we have the height, and then we have the base. So the base is this bottom side, but the height has to be drawn outside of the triangle. It's still saying the same thing, and it still uses the same formula that the area is equal to 1/2 times the base times the height. Now we can do some examples. If we have a triangle with a base of 13 centimeters and a height of 7 centimeters, then the area is equal to 1/2 times the base being 13 centimeters, times the height being 7 centimeters, now, you remember when doing perimeters, I started out by putting in the units, and then I just kind of eliminated them and said how I can just figure, at the end I can just add on the units. I'm leaving these units in here because I want to demonstrate what happens when you're finding area. When you're finding area, you're multiplying. So as we do this, I can multiply, remember order of, well, not order of operations, but commutative property of multiplication says I can move things around when I multiply. So I'm going to rewrite this a little bit. I'm going to say this is 1/2 times 13 times 7 times centimeters times centimeters. So 1/2 times 13 times 7 gives me 45.5. How did I do that? I said, well, I can multiply in any order I want. So I said 7 times 13, 7 times 10 is 70, 7 times 3 is 21. So I said that's 91. And then I multiplied by 1/2, which is the same as dividing by 2. So 91 divided in half by 2 is 45.5. But now I have centimeters times centimeters. Oh, centimeters times centimeters is centimeters squared. Anytime you have an area, the unit is going to be squared. If you have a perimeter or a distance, the unit is just going to be the unit. If it's in feet, it's feet. If it's in meters, it's meters. If you have an area, it's going to be squared. If it's in centimeters, it's centimeters squared. If it was in inches, it's inches squared. If it's in miles, it's in miles squared. So that's why I kept this in there to show what's happening. We also are multiplying the units. If we get into volumes, then it would be cubed because you'd have 3 dimensions that you're multiplying together. So you'd have inches times inches times inches, which is inches cubed. But area, the unit's always squared. And then for distances, perimeters, it's just the unit. For volume, it's unit cubed. Now, if I do not include a unit in the measurement, I don't require you to add it. Some people will say if they don't have any units on it, that after you've done your calculation, just to get all this out of here, right? After you've done your calculation, then you should say units squared. I'm not one who goes for that. If there's no units involved, just say 45.5. I'm okay with that. But if it has units, if it says meters, if it says feet, if it says inches, then it should be meters squared, feet squared, inches squared. So that's an example of a triangle. Well, I think rectangle and square are going to be pretty straightforward. If I've got 8 meters and 4 meters, then the area of a rectangle is just length times width, so 8 meters times 4 meters, 8 times 4 is 32, and meters times meters is meters squared. Now you realize, like I said, it started in meters. I know I'm going to end up as an area having it squared, so I don't really need to write in that meters. I could have just said 8 times 4 is 32, and then it was meters, so we make it meters squared. And of course, with a square, simple enough, if I have each side is 7 inches, then the area is going to be 7 squared, or 49 inches squared. I'm going to make that look just a little bit more like a 2. There we go. So 49 inches squared. So finding our areas. Now, as I showed previously with the perimeters, we don't always have nice pretty shapes like this. Now, we're not going to get as ugly as what we did with perimeters, but we can go back and look at some of the stuff we did there. What if I have a shape like this? And I say that this is 9 inches, that's 3 inches, 8 inches, and 2 inches. And I want to find the area of this shape. Well, it's not a triangle, it's not a rectangle, it's not a square, so what do? Well, to be honest, there are 2 ways that we can approach this. One is addition. With addition, we take this shape and we break it up into two shapes that we can work with, right? Now I have two rectangles. So I can find the areas of those two rectangles and then add them, thus addition. The other option is I can say, well, if I can find the area of this big rectangle and then the area of this rectangular piece that's not part of our thing, then we can subtract the missing piece from the whole, and thus we have deletion. We delete the missing part, and we end up with the area we're looking for. So we're going to do both examples just so we can see how that works. Now remember, when we have something like this, we're missing some of the sides, and that can affect us. Well, first of all, for this rectangle, that's not too bad. We have a height, we have a width, right? So we have length times width, so we can do that. So 9 inches times 2 inches gives me 18 inches squared is the area of that. 9 times 2 is 18, it's in inches, so it's inches squared. Now for this one, I don't have the length or the width because this 8 inches is the whole length. So I need to find out what's missing. Well, if this is 8 inches and that's 2 inches, then we can say that this is 6 inches. Or better, to make it so that it's less confusing when we look at it later, this is 6 inches. And if this is 9 inches and that's 3 inches, then what's left over here is 6 inches. So now to find the area of this rectangle, it's actually a square. 6 times 6, or 6 squared, is 36, so that is 36 inches squared. And then I can say that the area is equal to 18 inches squared plus 36 inches squared. 18 plus 36 is 54. So 54 inches squared. And I will point out that there are certain times with square that we actually can switch it. We'll sometimes say square inches instead of inches squared. We may say square meters, square feet, square miles. So it's okay to write that, to say that, and sometimes to write it, but it's good to get into practice of saying writing inches squared, feet squared. I mean, obviously you can use it the other way, but it's really good to get in this practice. But that is the exact same thing as saying 54 square inches. But it's best to stick with this. It's consistent. Okay, so that was using addition. We found the area of this one, we found the area of this one, and we added them up. Well, let's go the other way and do deletion. I'm going to use red for that just to keep it separate. By deletion, we're looking at the full area of this. So the full area is 9 times 8, or 72 square inches. That's the total area. And then we want to get rid of this, which is 3 times 6. 3 times 6 is 18 inches squared, right? So minus 18 inches squared, because that's the part that we don't want in it. And 74 inches squared minus 18 inches squared is equal to 54 inches squared. So it works the same way, comes out with the same thing. It's just a matter of, did we break it into pieces and add up those pieces, or did we find the whole thing and then subtract out the part we don't care about? So last thing we want to do here is deal with those algebraic equations again. A triangle has a height that is half the length of the base. Write an equation for the area of the triangle. Using one variable. Okay, so we've got a triangle has a height that is half the length of the base. Write an equation for the area of the triangle using one variable. Okay, so we know the area of a triangle is equal to 1/2 the base times the height. This tells us that the height is 1/2 the length of the base. So h is equal to 1/2 of the base. So now we can substitute that in for the area. So the area is equal to 1/2 times the base times 1/2 times the base. Community property of multiplication says I can move these around, so I can say that's 1/2 times 1/2 times b times b. 1/2 times 1/2, when we're multiplying fractions, we multiply across the top, multiply across the bottom, which gives me 1/4, and b times b is b squared. So now I have the area of this triangle can be found by taking 1/4 of the length of the base squared. So if I say that the base of this triangle is 8 meters, b is equal to 8 meters, and we want to find the area, 8 squared is 64. 1/4 of 64 is 16. So the area is equal to, we can put that as 1/4 times 8 squared, or 1/4 of 64. 64 divided by 4 is 16, and it was in meters. So remember, meters squared. So we're able to find the area of triangles, rectangles, squares, and any grouping of those.